Welcome to the experiment looking at heat packs, and this is investigation chemistry number 2. And in this investigation, you're going to be exploring the amount of heat released or absorbed by chemical reactions. I mean, you may have had an incident before where you're playing sport and you've hurt yourself, you need an ice pack, but you don't have one handy, you don't have ice with you. Then these packs you can crack, shake the chemicals inside. When the chemicals react, they actually react and absorb heat from the environment in order to make the chemistry go. Because they're absorbing heat, it means that you feel a loss of heat and it actually feels cold to your skin. Or you can have the reverse happen. You can have hot packs where you crack them, shake them, and when the chemicals react, they release heat, and that makes it nice and warm. So investigating chemical reactions in terms of energy release or absorption is an area of chemistry known as calorimetry. And you look at measuring temperature changes. And so in this example here with this investigation, you're going to be exploring something along the lines where it's called delta H. And the delta just means change. And in this case, the H means enthalpy, which is a big word to say the energy content of the chemical or of the system, right? So the change in energy, just think about it, is equal to minus m times c times delta T. Now, what does that mean? Well, m is the mass, and that's usually the mass of water that you're going to be using. C is called the specific heat capacity. And you've defined or you've found out the definition of specific heat capacity. It's the amount of heat that a substance absorbs. And by definition, 1 gram of the substance absorbs a certain amount of heat to raise its temperature by 1 degree. And water is amazing. It has a very high specific heat capacity. In other words, it takes a lot of energy to increase the temperature of water. And that's why we go swimming, because on a hot day, then that energy is absorbed by the water and from us to the water, and it feels nice and cool to us, but the temperature of the water doesn't go up very much. So specific heat capacity we're going to be using, and this is the temperature change. Okay, so that's what we're going to be looking at, and really, and what we're going to be doing at this level is working out Q, which is the same equation, but it's just looking at the energy change per the amount of chemical that you're going to be using. Okay, it's only when you do senior chemistry that we can see the relationship between this and what delta H is, right? So Q is going to have the same formula, right? And that formula is going to tell us how much heat is absorbed or released.
Sorry for the interruption.
Yeah.
Students who have returned from athletics, can you please make your way to the student office? If you've returned from athletics, can you please make your way to the student office now?
Okay, now we've had the announcements, let's get back to the chemistry. All right, so that's what we're going to be doing, and this is the equipment that you're going to have. You're going to have some styrofoam cups, and you're going to have a beaker, a measuring cylinder, the actual chemical you're using, a spatula. You're going to have what's called a weighing boat. That's where we put the chemical in. And then you're going to have some cardboard squares. And you're probably going to have of course, the data logger, which is a temperature probe. You would have downloaded the software called Pasco SparkView. Make sure that you watch that video, but I'll just show you very quickly how you connect this. So what you do is, I've got it on my phone. You can have the software on your phone or your iPad. I'm going to show you on my phone. And what you do is you're going to connect the probe, all right? And so what I'll do is I'll do it down here, and I'll make it close up so you can see what's going on. Okay, so if we put the probe near the phone so you can see, and you can see that when I've turned it on, it's flashing red, and so that means that it's turned on. It just needs to be connected. So what we do is we click on the Bluetooth icon, and now it's searching for the device. It's searching. All right, so you connect it. You can see the device there, the probe. You press on that, and it takes a little second, and then it connects. Now once it's connected, you just press done, and then you'll come to a screen where it shows you that there is a graph. Now that graph, you can actually record the temperature over time and it graphs it for you. But what we're going to do is we're going to press the little triangle symbol there, which then turns the page and it's going to give you a specific value. And so let's do that. And when we do that, you can see that's got nothing on there at the moment, 0. And then what we do is we have to press play. And when you press play, that tells that it's going to start recording the data. So if you press play, it then will tell you the temperature of the air. Then you can put it into your solution and then it records the temperature of your solution. Okay? So wherever you do it, it's going to record the temperature. And it actually measures the temperature on the tip of the probe. So if I place the probe on my finger, it's going to give me the temperature of the skin surface of my finger. Okay? And so that's how you use the probe. Now what you're going to do with the experiment, of course, is you're going to be measuring the temperature change of the chemical when it mixes with water. So of course you want a certain volume of water and keep the volume of water the same. You want your sample, so we've got some sodium chloride here. And then you want to go to an electronic balance and measure out a certain mass of sodium chloride and try and keep the mass the same too if you can. Now, when you record that, you need to tip your volume of water into your styrofoam cup. And that's part of the equation here. So M is the mass of the water. So if you use 100 mils, it's going to be 100 grams. Right, 100 grams. That's going to be times by a value for the specific heat capacity of water. Since it's the water that's going to be absorbing the energy from the reaction, then the temperature of the water is going to change. So we need to use a value here, and the value that we're going to be using is 4.18. And then we're going to be doing a temperature change. The final temperature minus the initial temperature. So what you have to do is, of course, you mass that out, you record the mass, you've got your volume here. Now, the card is to try and minimize heat loss. So you get a pair of scissors or something, you make a little hole in the top there, just enough so the probe can go through. You mix your chemicals together, stir it, right? Make sure it's, it's dissolved. And then you want to put your temperature in. Now, before, I should mention actually, put the water in first, record the temperature of the water, and that's going to be your initial temperature. Then, of course, you pour your chemical in and you give it a mix. You can mix it gently with the probe, not too vigorously. You don't want to just wreck it, so just mix it gently. And as you're mixing, then you're going to notice the temperature go down or up, depending on the chemical that you use. Once the temperature has stabilized, it's not changing anymore, that'll be your final, okay? And so when you do that, you'll end up with a number, and that's going to be the temperature change, that's going to be the amount of energy that has been released or absorbed by that particular chemical, all right? And then, of course, you do the same thing again, but you use different chemicals, all right? It's up to you whether you decide you want to repeat the process, okay? Think about that in terms of your experimental design. But at the end of the day, you're going to have 4 chemicals probably, and each of those chemicals are going to have either temperature going up or temperature going down per mass of chemical that you used, and then you have to think about how you're going to graph that. So that's what it's all about, the chemistry of heat release or absorption when chemicals are dissolved, and that is when we use this equation here. Hopefully it makes sense to you now. Good luck in your experiment, and I look forward to reading the results.